So in this lesson, we're doing equations of proportional relationships. So I want to give you the parts of an equation and how you'd break it down. The y is your y coordinates. If I were to graph it, it's how I'd go up or down. So the y coordinate, also known as the dependent variable from what we did last unit. The number that's touching the x, that's your constant of proportionality. And then x is your x coordinate, how you'd go left or right, also known as your independent variable. So I have a question that says, which has a constant of proportionality of 9, and I have A, B, C, and D. I want to look and see which one kind of has the qualities of this one, y equals 7x. So I'm going to look at them. This one's adding 9. So it's not constant. You just add 9 once. B, it's dividing by 9. Again, not constant. It's just dividing by 9. C, you're looking at it and kind of looks very similar to this. It's 9x, kind of like the 7x. And then D, it's just y equals 9, doesn't even have an x. So my one equation that has a constant proportionality of 9 is C. Something a little harder, or it says, what is the constant of proportionality for the equation x over y equals 2 over 9? How I like to solve this is using cross multiplication, also known as butterfly multiplication. So I'm going to say y times 2, which gets me 2y, and then 9 times x, which gives me 9x. So in order to solve this, to give you kind of what looks like here, where you have the y by yourself because you want it to be y equals your constant proportionality x, my whole goal is to get that y by itself. Not the x, the y. So like we always did, I put the line straight down. Because the 2 and y are touching, I know that's multiplication, so the opposite's division. I'm going to divide by 2 on both sides. We know those 2's cancel out, and I have y equals 9 divided by 2. And remember, I can just write as a fraction, 9 over 2, because the fraction bar means multiplication, and keep the x. You don't actually have to divide 9 over 2 because when we're using equations of proportional relationships, sometimes they're okay with just leaving it as a fraction form. So you do want to look at your answer choices and see, is it left as a fraction form or is it a decimal? In this case, we'll leave it as a fraction form. So your constant of proportionality is 9 over 2. For my next one, so I have which has a constant of proportionality of 0.7. So I have two different equations right here. And I see, again, I want to see which one has a constant proportionality of 0.7. So I'm going to do the same thing I did last one. Y times 7, which gets me 7y. 1 times x, which gets me x. I want to get that, I can write 1x, it doesn't matter. I want to divide by 7 on both sides, because remember, you want to get that y by itself. Divided by 7, divide by 7. 7's cancel out. I'm going to put y equals 1 over 7x. So obviously we need it in a decimal form, so I'm going to put the 1 on the outside, 7 on the outside to see what my decimal would be. Can't go in, so I'm going to put a 0 on top. Remember to add a decimal and a 0. 7 going to 10 one time. Notice how 0.1, 0.7, they're not the same, so I'm going to go to this one. Same deal, 7 times x and 10 times y. So I'm going to write 10y equals 7x. Again, your whole goal is to get that y by itself. So I'm going to say divide by 10 on both sides. And I know the 10's cancel out. I have y equals 7 over 10x. So again, I need a decimal form, so I'm going to divide. I have 7 on the inside, 10 on the outside. Remember, the top number always goes on the inside. 10 can't go in a 7, I put a 0. So I add a decimal and a 0. 7 going to 70 7 times. My constant proportionality is 0.7. I need a 0.7, so I know B is the answer. Looking at something like this, it says which equation best models the schedule below. So I have a schedule right here. And I have days 0 to 4, amount of money $0, $5, $10. So I kind of want an equation like we've been working at, where I have y equals 7x, or something where the y is by itself and the x is right there. So I'm looking for an equation like that. So I want you guys to always remember, when you're looking at a table, the x is always your first column, the y is always your second column, no matter what. So I'm going to pick any numbers to use here. I suggest do not use the zeros because they're not very helpful. I'm going to use the 2 and the 5. If you want to use the 4 and 10, that's okay, but I just like to use the smaller numbers. So I'm going to have my y is 5. So I'm going to write, instead of y, I know my y is 5. So I'm going to write 5 equals, I don't really know what the constant of proportionality is, and that's what I'm kind of looking for. So instead of writing my constant of proportionality, I'm just going to write C for constant of proportionality, and my x is 2. So C, 2. So my goal is to kind of find the constant of proportionality, because once I find that, it'll work for all these. So I'm going to put the line down. I want to get the constant of proportionality by itself, which is the C. So I'm divide by 2 on both sides. I know these 2's cancel out, and I have C equals 5 divided by 2, or I can just write 5 over 2. I know my constant of proportionality is 5 over 2. So an equation that would best match this would be y equals my constant of proportionality, 5 over 2, x. That equation will match every single one here. I know my x and my y's. X is your independent variables. Y is your dependent variables. And the last one I want to go through with you guys is actually up here. It says a fruit stand sells 8-ounce containers. Of blueberries for $4. If y represents the cost of x ounces of blueberries, which equation correctly models the proportional relationship? So when you're working with this, you know you have x and y. Your whole goal is to find the constant of proportionality. That's the hardest thing to find. So I know I have 8 ounces of blueberries and it's $4. It's very important you know what y and x are. I know y represents the cost. So I know the cost is $4. So when I write my equation, remember it's y equals your constant proportionality x. I know y is the cost, and I know $4 is the cost. I'm going to write 4 equals, we don't know the constant proportionality, so I'm going to write C. And I know x is the ounces of blueberries, and I know I have 8 ounces. So I'm going to write 4 equals C times 8. Same deal, you want to get that C by itself, so I'm dividing by 8 on both sides. 8's cancel out, and I have your C equals 4 over 8. And we know that can simplify to 1/2. So either 1/2 or 0.5. So if I wanted to write my constant, my equation, I have y equals 1/2 x. And another way you could write it, of course, is y equals 0.5x, because it's both 1/2. And I just want to make sure you guys realize I got the 1/2 by saying 4 over 8 is simplifies by 1 to 1/2. So either one of these work, both of these are saying the exact same thing.